Uh, we will talk about glass manufacturing. So, yung table of contents, number one would be the history and introduction, kung saan itatakal yung concept of the origin of the concept of glass manufacturing. Number two would be the terminologies, which is the most common terms that will be used or used in relation to glass manufacturing. Number three would be the glass, the definition of glass and important properties of glass. Number four would be the types of glass. Different types of glass will be discussed. Number five on the table of contents would be glass manufacturing. Here will be presented are the processes needed in the production of glass. And number six would be the references, where the literature, articles, web pages that are used excuse me, in this lesson will be presented. So let's go on first to the introduction and or history of glass manufacturing. Now in this section, we are going to learn about the history of glass manufacturing. So the ancient world. Glass is an independent object which is mostly made to a beads, which dates back to about 2500 BC. It originated perhaps in Mesopotamia and was brought later to Egypt. Now, vessels of glasses appeared about 1400 BC during the reign of King or Pharaoh Thutmose III. Now, as I've said earlier, Thutmose III is a pharaoh of the 18th dynasty of Egypt. Now, a glass bottle, as you can see in front of you, here is the glass bottle, is it is a glass bottle bearing Thutmose III's hieroglyph, which is makikita ngayon sa British Museum in London. So this is an example of Egyptians' earliest form of glass bottles. Now, from Mesopotamia and Egypt, glass making using basic soda lime silica composition traveled to Phoenicia along the coast of the present-day Lebanon. Now, from there, the art spread to Cyprus, Greece, and by the 19th century, even the Italian peninsula. Now, after the conquest of Alexander the Great in the 4th century BC, glass-making skills spread to the east, including the Indian subcontinent. Now, glass beads and bangles were made with characteristics of Hindu culture, which is founded about 200 BC in the Nivasa excavations. Now, glassmakers in Syria prospered during this time, where they specialized in plain bowls with single colors. So yung mga plain bowls na napoproduce that time is mga plain pa lang. For example, plain white, plain red, plain... so wala pang mga design. Sa Syria yon. Next would be the ancient world pa rin. In Alexandria, about 100 BC, is the Milfuri, or the Thousand Flowers. Now, in this process, a shaped core was made, perhaps of a mud, to which sections of colored glass canes were attached. Now, the core and the canes were placed into an outer mold to keep the shape, while the glass fused in an oven. Now, after removing the mold and the core from the oven, the glass surface were ground smooth. Now, cross-sections of the colored rods showed a striking mosaic effect. So we have an example here in front of us of what a Milfuri or a thousand flower glass would look like in the ancient times. Next is the Romans and Egyptians probably used sand mixed with ground seashells as a raw material for silica and lime. Hardwood as such for the source of soda. They also showed astonishing skills in the way they use metallic oxides as colorizers. So during that time, yung colorizers na ginagamit para sa different colors ng glass would be from metallic oxides. Very small differences in oxide content can drastically affect the final color of a glass. Yet colors and tints were reproduced time and again with remarkable consistency. For example, yung copper was used to make color green and ruby red glasses. Irons is used to produce color black, brown, and green. And tapos antimony is used to produce yellow, while manganese was employed to make purple and amethyst glass. Now, an opaque white glass is made by using a tin, was important in glass cameo work, of which the famous Portland base, as you can see in front of you, we have an example of what a Portland base would look like. It is made in the 1st century Rome. Now, it is an outstanding example of as I've said, of a Portland base. Now, to make this base, a layer of white glass was superimposed on a darker material and afterward sculpted, pierced, and cut away to leave the white figures in relief against the darker background. Hence, ito yung magiging kakalabasan nun. Next, let's go on to the Middle Ages and the Renaissance. Now, by the 15th century, Venetians had learned to make a fine rock crystal known as the Venetian Cristallo. So, kung nakikita nyo yung cursor, ito yung example ng Venetian Cristallo. Now, a beautiful colored glass and techniques for decoration. So, this is used for decorations lang. Such as gilding also were developed. Now, the Venetian product was exported to all over Europe and the Byzantine Empire. Now, by 1680, Bohemian crystal, basically a potash lime glass, was developed. So, ito ang example ng Bohemian crystal. So, as you can see, much clearer siya compared to the Venetian Cristallo. So, in 1674, George Ravenscroft of London experimented with the flint glass, a lead crystal composition which is made with a large proportion of calcined flints and potash. Now, by using 15% lead oxide, quartz pebbles imported from the Po River in Italy, and pure potash, he produced a fine, lustrous glass, soft enough to be cut and engraved easily, and of a greater refractive power than the common soda lime glass. So this is an example of what a flint glass would look like. Now, during the same period, Johann Kunkel in Germany developed a reliable formula for producing a ruby red glass using a gold chloride. So this is an example of what a ruby red glass would look like. Gold was dissolved in, this is produced by dissolving a gold in an aqua regia and mixed with a batch. Now, batch is when materials such as soda, sand, and lime was put together. So I would not explain what a batch. I would not explain furthermore what is a batch because it would be explained by my group mates later on. So next, let's go on to the science of glass. Now, the chemical revolution of the 18th and 19th centuries brought greater understanding of the principles of glass making. It was the French chemist Jean-Baptiste André Dumas who showed in 1830 that the durability of the soda lime silica glass was maximized when the ratio of the three was 1:1:6. This is essentially the modern soda silica composition. So, yung soda lime glass, kung maano nyo, ito yung ginagamit sa mga, nowadays, ito yung ginagamit sa mga soft drinks or yung mga yung mga binibili natin sa supermarket na mga babasagin na inumin. So, ito yung ginagamit, that's soda lime. Yung tawag dun sa type of glass na yun was soda lime glass. Now, in the 1932, William Holder Zachariasen published the atomic arrangement in glass. This is a classic paper that had perhaps the most influence in any published work on a glass science. Now, Zachariasen's work placed the understanding of glass structure and its relationship to the composition of its modern footing. So we have here an example of what a glass would or the atomic arrangement of a glass. Now let's go on to glass melting. During the late 17th century, cone-shaped or English glass furnaces using coal as a fuel appeared. Now the cones rose as high as 35 meters and were 10 to 12 meters in diameter. In these furnaces, covered pots for glass melting were placed on the middle level, slightly below the ground. Now, and an underground tunnel brought in high velocity upwards. And this is made because or to maintain significant higher temperatures for the creation of glass. Now let's go on to the flat glass. The Romans were perhaps the first to develop flat glass. For use, they developed it for the purpose of using it for windows in a bathhouse, which has a greenish blue color. Now, this is obtained mostly by casting. And examples of flat glass were discovered in the ruins of Pompeii. Now, beginning in the 1850s, however, the Chance Brothers factory in England successfully produced a variety of optical glasses using a melt stirring process. Indeed, one of the highlights of the Great Exhibition in 1851 was a disc of very homogeneous dense flint, which is 29 inches in diameter, as you can see in front of you. That's the optical glass that was made by the Chance Brothers. It is 29 inches in diameter and 2.25 inches thick. Now that would be all for the history of glass. Let's go on to the terminologies. In this section, we are going to know the different terms that are related to glass manufacturing. First is acid etching. Now this process for the decoration of glass involves the application of hydrofluoric acid to the glass surface. Now hydrofluoric acid vapors or baths of hydrofluoric acid salts may be used to give glass a matte, frosted appearance, which is similar to be obtained by surface sandblasting. As you can see, we have here an example of what would a glass would look like after acid etching. So this is, kung makikita nyo, mostly ito ginagamit to sa mga opisina. Next is acid polishing. A process used in the production of cut crystal to remove the opacity of each surfaces where decoration has been applied. Items to be polished are immersed in a mixture of demineralized water, sulfuric acid, and hydrofluoric acid, and then rinse. There may be a single short immersion in stronger solution, or alternatively a series of immersion in weaker solution. Next would be the bending. Bending is a process used widely in the production of bowl, bowls, plates, or ashtrays, and etc. Now, whereby the shape of the glass, which may be pre-printed, still in the sheet form, is placed on a stainless steel or a sheet steel or a cast iron mold coated with talc or powdered chalk. Now, the temperature is increased until the glass sheet sinks into the shape of the mold. Next would be coating. Coating is a thin layer which covers the surface of an object. Coatings may be applied to glass in order to alter the appearance and or the performance of the product in question. Now, anti-reflective coatings applied to auto mirrors to aid vision coatings with photocatalytic and hydrophilic properties to make self-cleaning windows. So this is an example, as you can see, this is an example of a glass without coating, and this part is an example of a glass with coating. Next would be edging. Now, the shaping or finishing of the edges of a glass surface, usually by grinding with an abrasive wheel. Next would be glass ceramics. Now, materials produced from glass which have a fully crystalline structure most offer advantages of low thermal expansion, making them suitable for uses such as cookware. Others have high physical strength and can be machined like metals. So yung glass ceramics, probably makikita natin to in kitchenwares, yung mga bowls, yung mga bowls natin which pwedeng i-microwave. Next would be glory hole. Is a hole in the side of a glass furnace which is used to reheat glass that is being fashioned or decorated. Now, the glory hole is also used to fire polish cast glass to remove imperfections remaining the mold. Next would be leer, a special type of oven or kiln used specifically for annealing glass. In industrial production, it usually has a moving belt to carry the glass through a controlled speed and is divided into different areas, each with its own heat source, making it possible to carefully regulate the temperature gradient to which the glass is submitted. Next is limestone. Now, limestone is a sedimentary rock which is composed mainly of calcium carbonate, which is added to the batch to provide calcium oxide. Next would be pyrometer. Pyrometer is an instrument used to measure the temperatures inside the furnace or kiln. Next would be rolled glass. Rolled glass or cast glass is a translucent glass with 50 to 80% light transmission. Depending on its thickness and type of surface, it is used where transparency of the glass sheet is not important or not desired. Next would be screen printing, a process for the decoration of glass whereby colored ink is forced by a flexible squeegee through a fine mesh screen or a mask. This is traditionally made from silk, but nowadays, it is also made from nylon, polyester, and stainless steel. A separate mask is used for the application of each color. So yung yung screen printing na process would be, makikita natin to sa mga ganitong klase ng bottles, sa mga perfumes, and yung mga ginagamit sa mukha, mga products that uses glass bottles. Next would be silica. Silica or silicon dioxide is a mixture that is the main ingredient of a glass. The most common form of silica used in glass making has always been sand. Next is viscosity. Now, the quality or state of being viscous, the physical property of a liquid or semi-liquid that enables it to develop and maintain a certain amount of shearing stress dependent upon the velocity of flow and then to offer continued resistance to flow. Last, for the or this section would be wired glass. Now, the wired glass is a flat rolled glass which is reinforced with wire mesh and is used especially for glass doors and roofing to prevent objects from smashing through the glass and also to hold pieces of broken glass together. Now, by holding the glass together, it can also protect against break-in and spreading of fire. So that would be all for my part.
So for the section 3, glass, in this section, the definition of glass and its notable properties will be discussed. Glass is a unique and extremely versatile materials that can be engineered to exhibit specific optical, thermal, chemical, and mechanical properties. As a result of its exceptional engineering properties, transparency, strength, workability, transmittance, and U-value, has been heavily used in the constructional industry. We will briefly feature some of the most common commercial glass type and typical applications. So the properties: absorbs, refract, or transmit lights. It can be made transparent or translucent. Second is it can take excellent polish. Third, it is an excellent electrical insulator. It is strong and brittle. It can be blown, drawn, or pressed. It is not affected by atmosphere. It has excellent resistance to chemicals. It is available in various beautiful colors. With the advancement in technology, it is possible to make glass lighter than cork or stronger than steel. The last is the glass panes can be cleaned easily. Kung makikita natin, itong mga glass na to is madalas nating siyang may mapanood sa mga Facebook, ganun. So, sa section 4 naman is yung type of glass. In this section, the different types of glass available in the market will be discussed. So yung una is yung soda lime glass, also called soda lime silica glass. It's the most prevalent type of glass used for window panes and glass containers, bottles and jars for beverages, food, and some commodity items. Some glass bakeware is made of soda lime glass as opposed to the more common borosilicate glass. So yung soda lime glass is yung most of the common type of glass which accounts for 90% of manufactured glass. So makikita natin siya madalas sa mga pamilihan, yung mga supermarket. Ginagamit siya as a bottle sa mga inuman. Ganun. So yung next is yung flint glass, is combination of silicon dioxide with lead or potassium. It creates a relatively high refractive index and high degree of light dispersing power compared to other type of glass. Flint glasses are arbitrarily defined as having a ab number of 50 to 55 or less. So yung next naman is yung sa potash lime glass. Yung potash lime glass is similar lang sa soda lime glass except na mas mataas yung high melting point and can withstand high high thermal stresses. It is mainly a mixture of potassium silicate and calcium silicate. It is known as hard glass. It fuses high temperature. It is used in manufacture of glass articles which have to withstand high temperatures. Yung next naman is yung borosilicate glass. It's a type of glass that contains boron dioxide which allows for a very low coefficient of thermal expansion. This means it will not crack under extreme temperature changes like regular glass. Its durability has made it the glass of choice for high-end restaurant laboratories and wineries. So yung borosilicate glass is madalas natin makikita sa mga lab. Ayun yung mga dalas na ginagamit pag may ginagawang experiment. Yung next naman is yung flux glass. In this glass, mainly cerium oxide is present which sharply absorb the ultraviolet rays from the sunlight, so utilized in making lenses of eyeglasses. So ito is madalas na makikita na ginagamit sa mga eyeglasses. So yung next is yung quartz glass. Is an extremely versatile material used in a range of different application. It has outstanding thermal properties, excellent optical transmission, with good electrical and corrosion performance. Yung next naman is yung opal glass. Is a milky white glass that is prepared by adding impurities which disperse as crystallities within the matrix of glass, and that is used especially for ornamental pressed glass and for diffusing lights without serious loss of lighting efficiency. Yung next naman is yung glass wool. Is an insulating materials made from fabric of glass, arranged using a binder into a texture similar to wool. Glass wool and stone wool are produced from mineral fibers and are therefore often referred to as mineral wools. Mineral wools is a general name for fiber materials that are formed by spinning or drawing molten materials. Yung next naman is yung sa aluminosilicate glass. It is a type of glass that contains aluminum oxide, usually at level between 20% and 40%. There are different types of aluminum silicate glass, and they depend on their chemical composition with a particular focus on the oxide composition. So, ito ata is yung madalas na ginagamit sa mga as tempered glass, yung mga ganan. So, yung next naman will be reported by person.
So for a glass manufacturing process, this part covers a discussion on how glass is produced. So the first step is collection of raw materials. Depending upon the type of glass to be manufactured, suitable raw materials are collected. So dito may table tayo wherein it shows the raw materials used for each type of glass. Sa una is soda lime glass. Ang raw materials na ginamit is chalk, soda ash, and clean sand. For potash lime glass, ang ginamit naman ay chalk, potassium carbonate, and clean sand. For potash lead glass, ang ginamit is litharge or lead sesquioxide. potassium carbonate, and pure sand. And for common glass, the raw materials are chalk, salt cake, coke, and ordinary sand. For second step naman is preparation of batch. The raw materials, cullet and decolorizer are finely powdered in grinding machines. These materials are accurately weighed in correct proportions before they are mixed together. The mixing of these materials is carried out in mixing machines until a uniform mixture is obtained. Such a uniform mixture is known as the batch or frit, and it is taken for further process of melting in a furnace. The third step is melting in furnace. The batch is melted either in a pot furnace or in a tank furnace. The heating is continued until the evolution of carbon dioxide, oxygen, sulfur dioxide, and other gases stops. Sa pot furnace, a pot is a vessel made of fire clay. This process resembles the crucible steel process. These pots are placed in specially prepared holes in the furnace. The charging and collecting of doors are kept projecting outside so that the raw materials may be added and molten glass may be taken out conveniently. Sa tank furnace naman, this furnace resembles the laboratory furnace adapted for puddling of the wrought iron. It is constructed with reinforced masonry. The roof is given a special shape to deflect the flames of the heated gas. So, sa fourth step naman is fabrication. The molten glass is given suitable shape or form in this stage. It can either be done by hand or by machine. The hand fabrication is adapted for small-scale production, and machine fabrication is adapted for large-scale production. So, meron tayong iba't ibang uri ng types ng fabrication. The first one is blowing. The operator then blows vigorously from other end of blowpipe. It can be done with the help of an air compressor. This blowing causes the molten mass to assume the shape of the cylinder. It is then heated for a few seconds and it is blown again. Next is casting. The molten glass is poured in molds and it is allowed to cool down slowly. The large pieces of glass of simple design can be prepared by this method. It is also adapted to prepare mirrors, lenses, and many more. Next is drawing. This process consists in simply pulling the molten glass either by hand or mechanical equipment. An iron bar is dipped sideways in the molten mass of glass. It is lifted up horizontally and in doing so, it catches up a sheet of molten glass. This sheet is allowed to pass over a large rotating roller. The roller helps the molten glass to spread in the form of a thin sheet. Next is pressing. In this process, the molten glass is pressed in molds. The pressure may either be applied by hand or by mechanical means. This process is adapted for ornamental articles, hollow glass articles, and etc. Next is rolling. There are two methods of rolling. In one method, the molten mass of glass is passed between heavy iron rollers and flat glass plate of uniform thickness is obtained. In another method, the molten mass of glass is poured on a flat iron casting table and it is then turned flat with the aid of heavy iron roller. And lastly is spinning. In this process, the molten glass is spun at a high speed by a machine to form very fine glass fibers. This glass has tensile strength equal to that of mild steel. It does not fade, decay, or shrink. It is not attacked by acids, fire, and vermins. It is very soft and flexible. It is used for providing insulation against heat, electricity, and sound. Sa fifth step naman is annealing. The glass articles after being manufactured are to be cooled down slowly and gradually. This process of slow and homogeneous cooling of glass articles is known as annealing of glass. meron tayong two types ng annealing. First is flow treatment. In this method, a long flue is provided and it is constructed in such a way that there is gradual decrease in temperature from one end of flue to the other. The red hot articles of glass are allowed to enter at the hot end of flue and they are slowly moved on traveling bands. They become cool when they reach the cool end of flue. This method is useful for large-scale production. Next type is oven treatment. In this method, the red hot glass articles are placed in ovens in which arrangement is made to control the temperature. After articles are placed in the ovens, the temperature is slowly brought down. This method is useful for small-scale production. So magpi-play ako ng video kung saan pinapakita yung glass manufacturing process.